Okay, so in this section, we're going to be talking about how to identify the graphs of functions and what different things do to a function. So if I were to multiply a function by by some number, or if I were to multiply the variable by some number, what that does. Okay, so the first thing we're going to talk about is how to identify whether a graph is a function. So if we were given an actual graph, whether that is a function or not. Okay, and we're going to do that by something called the vertical line test. Okay, so the vertical line test is basically, so if you were to read the definition of it, or the theorem, it says a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph at most one point. So basically what it means is that if I were to draw a vertical line anywhere on my graph, it should never intersect the graph more than once. So let's take a look at this example. It asks which of these are functions. Okay, so I'm going to take a look at part A. Okay, we actually have a parabola here. So if I were to draw a vertical line anywhere on this graph, okay, notice that these vertical lines will only ever intersect our graph exactly one time. So this would be an example of a function. So my answer would be yes, it is a function. All right. Okay, let's look at part B though. All right, let's check this one. So if I were to draw a vertical line anywhere on this graph, okay, so just draw a bunch of vertical lines, notice that again, my vertical lines never intersect more than once. Okay, so it never intersects my graph more than once. So again, this is another example of a function. Okay, so let's take a look at part C. Right? And automatically you should be able to tell that this is not a function. So notice that if I draw a vertical line here, it crosses through 2 points. So if I drew a vertical line at x equals 1, we have a point at 1 positive 1, and we have a point at 1 negative 1. So we put one thing in, but we got two different solutions out. Okay, and that happens on every point except for this 0. So if I plugged 0 in, we actually get 0 back out. Okay, so this is not a function. All right, what about part D? Part D is a circle, and again, just by looking at it, if we were to draw a vertical line anywhere on our graph, notice that they do again intersect our graph at more than one place. Okay, so as soon as it intersects more than one time, we can call that a non-function or not a function. All right. So the next thing I'm going to do is I'm going to talk to you guys about how to actually read a function. Okay, so if I were to give you a graph, what that actually means. So the first thing I want you guys to do is on this graph, there's actually a typo or an error. There's an arrow on the right-hand side. I want you to go ahead and cross it off. I want it to actually end at that decimal place. So go ahead and cross that off, or white it out, or whatever you need to do to make sure that it ends at that decimal place, or that point. Okay, so this first part A, so it says let f be the function whose graph is given to the right. We want to know in part A what f of 0 is. So remember that we're dealing with functions evaluated at x, so f of x. So 0 in this case is actually going to be our x value. Okay, so what I'm going to do is I'm going to look on my graph where my x is equal to 0. So in this case, my x is 0 right here. Okay, so if x is 0 here, what is my f of x? Well, my f of x, or my f of 0, is going to be at 4. Okay, so f of 0 is actually equal to 4. Okay, and so let's go ahead and take a look at f of 3 pi over 2. Okay, so again, this is your x value that you're looking for. Okay, so f of 3 pi over 2, well, we're looking for it over here, so it's right here. And notice that my y value for this is actually 0 because it's on the x-axis. So f of 3 pi over 2 is actually equal to 0. Okay, and then we're going to take a look at this last one, which is f of 3 pi. So 3 pi is right here. Okay, so this is 3 pi, and I'm going to look at where the line is, which is right here, and it is at -4. So f of 3 pi is actually equal to -4. Okay, and that's all we're looking for here. All right, what about the domain? So the domain of x is how far to the left and to the right our function is going to go. So notice that your left and right, remember, is your x variable, right? So we're looking at how far from here to the right it goes. So it goes all the way from, this would be 0, all the way up to, and it should end right here at 4 pi. Okay, so we need to make sure that we write this in proper set notation, right? So our x values are going to range from 0 all the way to 4 pi. Okay, so the way I'm going to write that is that the domain is a set. Okay, and again, we're dealing with x's. So the set of all x's such that 0 is less than or equal to x, right? So 0 is the smallest it'll go, and x is less than or equal to 4 pi, which 4 pi, recall, is the largest it gets to. Okay, so again, the domain is how far from the left to the right my x values go. Okay, and again, that's why we marked out this arrow, because I wanted to actually end there. All right. Next, it says, what is the range of f? Okay, so what is the range of f? So range is how far up and down this function goes. So it's how far up or down this function can go. So in other words, it's your possible y values. Okay, so notice that here, the lowest my function is going to go is down to -4. So it goes all the way down to -4. And the highest it gets is up to +4. Okay, so my range is from -4 to +4. So since we're dealing with range, and range is up and down, we're actually going to use y instead of x. Okay, so range deals with up and down, so that means we're going to be dealing with y instead of x. So I'm going to say that the range is a set of all y's such that, and now this is our condition. So remember that this part is always the condition. So the low part is -4 less than or equal to y less than or equal to 4. Okay, so y has to be between 4 and -4 inclusively. All right, so I'm going to have to erase a couple of things so we can kind of see what's going on here for the next couple of parts. All right, so now it says we want to list all of the intercepts. So remember that whenever we're dealing with intercepts, we actually have two different types of intercepts. We have y-intercepts, and we have x-intercepts. Okay, so y-intercepts, recall, is where it crosses the y-axis, and x-intercept is where it crosses the x-axis. So let's take a look at this graph really quickly and determine where it might cross through the y-axis. Okay, and notice that the only place that it actually touches the y-axis is at 4. So my y-intercept is at y equals 4. Okay, and that's all we have to do for the y-intercepts. Now taking a look at the x-intercepts. Okay, so x is equal to, well, where does it cross the x-axis? So in this case, it crosses the x-axis here, 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 and here. Okay, and so all I'm going to do here is simply write those numbers. So it's pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. And there we have it. Okay, so those are my intercepts. Okay. Part E is asking us how often does the line y equal 2 intersect the graph. So remember, y equals something is going to be a horizontal line. So taking a look at this graph, if I were to actually draw a horizontal line through this, okay, so as horizontal line y equals 2, it would go through like this, right? So this is the line y equals 2. How many times does it intersect? Well, it's 1, 2, 3, and 4 times. So it intersects the graph 4 times. So the last couple of these, it's asking us for what values of x does f of x equal -4. So it's possible, and just because this is a function doesn't mean we couldn't have multiple values of x. We're looking at any time our f of x is actually equal to -4, or where it's equal to -4. So x is equal to, okay, and we're going to take a look at this graph and look for y equals -4. So y equals -4 is right down here on this line. Well, where exactly is it crossing through here? So there's 1 point here, so that would correspond to pi, and we have 1 point here, which that one corresponds to 3 pi. So those are the 2 points where our function is actually -4. Okay, so I'm going to go ahead and put that in here. So x is equal to pi and 3 pi. Okay, so again, we're just looking at where vertically does it cross through the -4. So where does it go through here? All right. Now, the last part is asking for what values of x is the function greater than 0. Okay, so we're looking at where, so remember, f of x is equal to y, so we're looking at where our y values are greater than 0. Okay, so if we're taking a look at this graph, let me use a different color here. If we're taking a look at this graph, notice that the places where it's greater than 0 is where it's above the x-axis. Okay, so it's greater than 0 here, here, and here. Okay, so we're going to go ahead and write those intervals. And that's what we're asking for here. So on this first interval, this first hump, it goes from 0 all the way up to 2 pi. So I'm going to have to write that as an interval. Okay, so I'm going to say that f of x is above 0 from 0 all the way to 2 pi. Sorry, not pi, 2 pi, it's pi over 2. My bad. All the way up to pi over 2. Okay, then it goes below the x-axis, so it's no longer, f of x is no longer above 0. And then from 3 pi over 2 to 5 pi over 2, it again goes above the x-axis. So I'm going to go ahead and, again, I'm going to say 3 pi over 2, comma, 5 pi over 2. Okay, so again, this is another point where it goes above the x-axis. Okay, and then lastly, it goes, again, it goes back, it dips below the x-axis. Okay, so this one would be f of x is less than 0. And then up here, again, it goes back above it. So it goes from 7 pi over 2 up to 4 pi. Okay, and again, that's where we're going to leave it. So one thing I want you to notice is that I'm using a mixture of brackets and, brackets and parentheses. So remember that to be a bracket, it means that you include it. So if I use a bracket, it's included. So in this case, 0 is included and 4 pi is included, where if I use parentheses, it is not included. Okay, so I want you to think about why I'm not including these values here. Why am I not including any of these? Okay, and the reason is that if we actually took a look at this graph, notice that these points, so where it actually crosses through, it's no longer above or below the x-axis, it's actually equal to the x-axis. And since we're looking for where it's strictly above the x-axis, we can't include those points. Okay, so if this had an underline under it, we could include those points, but in this case, since it does not have that underline under it, we would have to exclude those points. Okay, so these are all intervals. Okay, so these are intervals where it's above the x-axis. All right, so enough of looking at the graphs. Let's go ahead and take a look at a function and kind of pick some parts out of it using some information that we already know. All right, so consider the function f of x is equal to x plus 1 divided by x plus 2. We want to know, is the point 1 comma 1/2 on the graph? Okay, so remember that your coordinates are always x comma y. Okay, now in order to determine whether a point is on the graph, if I were to plug in any x value, I should get out this. So this is your input, and this should be your solution. Okay, so all we're going to do here is we're just going to test. So we're going to say, well, what is f of 1? Okay, so our goal, we should have f of 1 equals 1/2, right? So that's what we should end up with. Well, let's check. So we have f of 1 is equal to 1 plus 1 divided by 1 plus 2. Well, 1 plus 1 is just 2 divided by 3. And notice that this is not 1/2. So our answer here would be no. The point is not on the graph. And again, it's because if we plug in our input, we do not get the same output. Okay, so let's take a look at this next part. It says, if x is equal to 2, what is f of x? Okay, so if x is equal to 2, what is f of x? So what it's actually asking us to do is simply to evaluate f at 2. Okay, so in order to do this, we're simply going to say, well, this is 2 plus 1 divided by 2 plus 2 is equal to, well, 2 plus 1 is 3 divided by 2 plus 2 is 4. Okay, and that is what f of 2 is. Okay, the second part is it's asking us to find the point on the graph. So the point on the graph, remember, again, it's just x comma y. Okay, or you could think of it as x comma f of x. Okay, so we know that x in this case is 2, and we know that f of x or y, so these are your output or your solution. Okay, and again, that's all I'm looking for here. Okay, what about this next one? Well, this next one says, if f of x is equal to 2, what is x? So recall that f of x is equal to x plus 1 over x plus 2, right? So if f of x is equal to 2, then all I'm going to do is I'm going to take that f of x and I'm going to replace it with the 2. So I'm going to say that instead of having to plug it in, I'm going to say 2 is equal to x plus 1 over x plus 2. Okay, so this is actually the hard part, is solving for x. So on this, what I'm going to do is I want to get rid of this denominator, and I'm going to do that by multiplying both the right and left side by whatever that denominator is. I'm going to say x plus 2 times x plus 2. Okay, and that gives us, well, x plus 2 times 2 would be 2x plus 4. Okay, and over here on the right-hand side, the x plus 2's actually cancel out. And all I'm left with is x plus 1. And now it's just a simple simplifying or solving for x. So I'm going to subtract x from both sides. And I have x. I'm going to subtract 4 from both sides to get my x by itself. So I get x is equal to -3. If you need help getting straight from here to this point, just let me know, and I'm more than happy to help you out. All right. And then the second part is, again, asking us to asking us what the point is on the graph. So remember that the points are x comma y. We know that our x value is -3, which means that our y value is what we set everything equal to, which is 2. Okay. Again, there's our solution. All right, lastly, it says, what are the x-intercepts of the graph, if any? And then don't worry about the second part. All right, so x-intercepts. So remember, to be an x-intercept, that means that y has to equal 0. Or in this case, f of x has to equal 0. Okay, so it's going to be very similar to part C, where we're setting everything equal to 0 because, again, we're saying that y is equal to 0 or f of x is equal to 0. So I'm going to say 0 equals x plus 1 divided by x plus 2. Okay, just like before, I'm going to multiply both sides by the denominator. Right, and over here, I am left with 0, so this gives us 0 is equal to. These cancel out on the right-hand side. Okay, so this gives us 0. These divide to 1, and we're left with 0 equals x plus 1. And again, now we have a simple one-step equation, which gives us x equals -1. Okay, and if I were to ask you what is that point on the graph, well, it would be -1, comma 0. Okay, and that's all you got to do there. All right, example 4. We are going to be doing on our calculator. So I will post a separate video using the graphing calculator to show you guys how exactly to work